Hello, chemistry students. This is your lesson over the periodic properties lab that you're going to be doing soon. You remember in our discussion of the history of the periodic table, we mentioned how Dmitry Mendeleev had actually been able to determine characteristics, properties of elements that had not yet been discovered. Well, guess what? In this lab, you get to play Mendeleev. In other words, what you're going to be doing is measuring the density for 3 elements in group 4 and then using that data to determine the densities for 2 other elements in that same group. Now, in the last video, we talked about the elements that you need for an appropriate pre-lab write-up. Remember, when you come to class to do this lab, you must have a pre-lab completely done, ready to be graded, and closed-toed shoes. There will be no doing the data table while you're collecting the data. Here's what you need to have. You need to have a title, the purpose, a procedure, and a data table. And remember, this is in the results section. Now, for this lab, because it's our first formal lab write-up, we are going to give you quite a bit of help with this one. Anything that we give you, you can use as is. But keep in mind, the idea is for you to learn how to do this so that eventually you will be coming up with this all on your own. The first thing that you'll need after your title is a purpose. Remember the elements that we need for a good purpose. We need to explain what it is that we're trying to determine by doing the experiment, how we are going to determine it, and the things that we're going to be using or the process that we will be using in order to make that determination. Here's the purpose for the experiment that you're going to be doing. As I mentioned, we're going to be determining the density for 3 of the group 4 elements. Those elements are silicon, tin, and lead. So those are the things that we're going to be using. And that is the purpose of doing this experiment. In order to do that, we are going to use the process known as volume displacement. Not only have you done this before, you were tested on it in the Unit 2 practical. So I hope you remember how to do that. We are then going to take those density values for silicon, tin, and lead and use those values to estimate densities for carbon and germanium. Note that carbon and germanium are elements in the same group as the other 3. Here are the materials that you are going to be using. I mentioned in the pre-lab discussion that your teacher may or may not require you to include a materials list. Whether or not you include a materials list, you must indicate these specific items as part of the appropriate step in the procedure. You will be wearing goggles. You will be using a balance to mass the elements. You will be using a large graduated cylinder and a small graduated cylinder. It says 100 milliliters, but if your largest graduated cylinder is 50 milliliters, that will work fine. You're also going to be using 3 different elements. We're going to show you that in a minute: silicon, tin, and lead. This is silicon, and that in a weigh boat is what 5 grams of silicon would look like. Here's tin, that's approximately 10 grams, and there's lead, approximately 25 grams. You don't have to try and get exactly these masses, but you want to get close, and you certainly don't want to go much above those values. And then finally, you'll be weighing those elements in a weigh boat.
Oh, sorry. I had something caught in my throat there. Okay, so after that, let's talk about your materials, your methods, and your procedure for your lab. For the purpose of your lab, I'm going to show you an example here. Now, the example is written to show you how you would do it if you happen to be using your sample of silicon first. However, I recommend that all of you do not write the exact same procedure and start with silicon. Otherwise, you're going to spend a lot of time sitting around and waiting. So I'm going to go through the example as if you're starting with silicon, but you probably want to go ahead and start with something else. Some of you can start with silicon and some of you start with something else. That way everybody's not standing around wasting a bunch of time. All right, whichever one you decide to start with, the first step is to go ahead and get your samples. You're going to take your samples back and measure the appropriate amount out using the scale. Remember, each of the 3 different samples have a required different amount of weight. And do not waste your time trying to get exactly 5 grams or 10 grams or 25 grams. Get somewhere in the ballpark of that and write down the actual amount to the nearest thousandth of a gram. After that, you're going to need to find the volume. Remember, to find the volume, you fill up your graduated cylinder. You're going to write down the initial volume. You're going to add your sample, write down the volume again with both the water and the sample. And then later, you're going to go through and write down the actual volume of the sample. You can't write that down yet because you need to show the actual calculations in the calculation section. Now again, depending on which sample you start with, you might be using a different graduated cylinder. If you're doing silicon, you're going to want to use your large graduated cylinder, the 50 or the 100, because it will get stuck in any of the smaller ones. If you start with your tin or your lead, you're going to want to go ahead and use one of your smaller graduated cylinders because it will have a greater precision in its measurements. Okay, now assuming you're using the silicon again, or whichever one you happen to be starting with, make sure it is completely submerged before you do your second measurement with the water and sample combined. This volume then will be recorded in your data table. As you go to empty your sample out, whichever one it is, be very careful not to let it fall down the sink. The lead and tin especially are very prone to falling down the drain and clogging up our drains and losing all of our sample. So please be very careful to block it with your finger or catch it in your hand as you empty the water out. When you're done with that sample, you're going to need to return it without using your weigh boat to a collection area that your teacher will provide for the wet sample. Do not get your weigh boat wet, and do not put it back in the original container you got it from, because with wet sample in there, it'll throw off everyone's mass measurements for the whole rest of the day. Make sure it goes back only in the wet sample container that your teacher has provided for that type of metal. Do not mix the types of metal ever. Once you have completed doing all the measurements for one type of metal, then you can go up and collect your second type of metal and repeat the entire procedure again. Again, remember to return it to the correct spot in the wet samples, not the originals, and in the correct place. Then you can go back and get your third sample and do it all over again. Okay? Make sure when you're writing your procedure that you specify which size of cylinder you should use for each type of metal. Now, when you're writing your procedure, it is perfectly okay, like in our example here, for you to go ahead and use repeating the steps over again for 10 grams of tin and 25 grams of lead. That way you don't have to rewrite the procedure over and over and waste a bunch of time. The next part of your lab should contain a data table. Remember, a data table should be fully boxed in and drawn with a straight edge or ruler. Remember, you should have the appropriate labels. This data table is a perfectly fine example of what you want to use. If you can make one that looks just like this, that'll be perfectly fine. Notice that it has a title and labels. Remember that as you go through and record your data on a lab can only be recorded in
pen.
That's right, in pen. Now, the appearance column in the bottom there, if you're curious, row, excuse me, is basically there for you to write some brief observations about what size each of the sample is and what they look like. That way, if your data turns out to be very strange and we'd like to go back and find out why, your instructor can go back and figure out if you've somehow managed to mix up one of the samples. Well, that pretty much wraps it up for this activity. You guys are going to have a chance to come in tomorrow and ask any questions you'd like to ask about either writing a pre-lab or about this specific activity. Now, if you want to go ahead and start writing it now, you're more than welcome to. But if you feel like you need to wait and ask some questions first, you can wait. We'll talk to you tomorrow in class, and we'll be ready to go.